Thank you. Well, first of all, thanks for being here. Thanks for sticking around so long. It's the last track at the second day in the second room here. Yeah, my talk, Running a Tight Ship, Security Model for Docker Environments. Welcome. A disclaimer first. I specifically chose the desert, so it might be a little dry and technical. The good part is it will only last 45 minutes, max. It's not a hacker talk, and I'm not one. I left out networking specifically as it would require a separate talk. And there's no silver bullet, so I don't have any easy answers for you. At least there's not one, but maybe multiple. So I will try to focus on the system aspects, and yeah, would like to share a security model that my colleagues and myself developed during the last 2 years, basically, working in environments that are moving from a physical/virtual machines-centric approach into going into the container/Docker space. And by working with the infrastructure aspects and implementing those, we also dealt with bringing in security measures into those environments. A couple of words about myself. Yeah, I'm Dustin, working for Cassini Consulting, go by the Twitter handle of DHPTS. And mostly work in the infrastructure system architecture field, and besides security, also working in the networking layer. So last year, a couple of clients actually were trying to move from going from the development or integration state with their Docker implementations into production. So the question was, are we ready for liftoff? Could we now go into production? And so we ask ourselves the questions, okay, what does this mean and have implications on the system architecture? Questions like orchestration, integration into the existing continuous delivery pipeline. There's many images spread out across multiple hosts when you run Docker on all of those. Questions regarding logging and especially monitoring and debugging those systems. And last but not least, security. Is my security model that I might have developed in the past couple of years still valid, or do I have to think about changing this model and approaching things differently? So why is security in regards to Docker interesting? Maybe to just have a look at the timeline. On the upper side, there is a couple of challenges that Docker had in the past years, starting in 2013. Of course, it was great that Docker started to implement networking into our stack and have a remote API, so that's good for usability. At the same time, this dramatically increased the attack surface, on the other hand. If you rely on the public Docker Hub registry, there was an authorization bypass and also an outage. So if you try to compile a new image based on some base images that are on the public Docker Hub, this would have been an issue at that time frame. On the other hand, from my perspective, Docker started to figure out that security is an issue and is something to be dealt with because there's demand in the market regarding that. So they try to implement measures to actually improve security. And I would say the story somehow changed from Docker versus security to Docker and security. So now you have a couple of individual measures and tools that need to be combined. And basically the question is, how would you approach that, and how do you combine those? So we try to create a model, a security model that gives you the possibility to actually make sure that most aspects are covered when you're trying to implement an environment that runs Docker containers, and also make it reproducible in different environments. So the model starts with the build chain. Originally, of course, that's the two factors here on the side, would start with compiling binary code. You probably over the time would add testing, dependency resolving, packaging, maybe even creating virtual machine images, and now, lately, creating Docker images. So this Docker security topic starts right there in the build chain. Station 2 of the model would be the registry itself. So this is the place where the images would be pushed to after building them, using those nice little trucks there. And of course, this generates a new set of questions. Where are my images being stored? public registry? Is it a private on-premise registry? How do I make sure that only my uploaded images are being executed in my environments? How could I make my images available to others? And how can those be sure that the images are actually coming from me? How do I know what my images are based on? We'll get to that later. So moving on to the third station, the Docker host. Basically, when we discuss security in regards to the Docker host, it's very common sense securing and hardening of the host. And this would then be followed by, let's say, the cheesy bits of the Docker daemon in station 4, because some might already have heard it. The Docker daemon is running as root, and of course this raises questions of container isolation and how to control access to the API. So, and then the final step, after creating, transporting, and accessing the images, would be to actually run them. So we'll also look into that. So let's start with the build chain. Station 1. It's where the Docker images are being created from infrastructure and application artifacts. So historically, I already went to that. A build chain is being used to create a tested code artifact and actually ship this to multiple environments. And when you already are in a position that your build chain is, besides binary code, also producing virtual machine images, you're already pretty close to the aspects of how to create Docker images. And of course, it would be nice to actually apply the same quality and security measures to those Docker images as you would to the other parts that are running through your build chains. But then one of the questions would be, which version am I using of all the software components and the images, and how does it fit all together? So speaking in extremes, there's two opposed models. One would be latest and greatest versus pinned versions. So latest and greatest, it's easy when you always want to rely on the latest features and security bug fixes available, but at the same time, gives the difficulty of actually making sure that your software components run with the latest and greatest base images and runtime environments, for example, like Nginx, Tomcat, Ruby, you name it. So you would have to make sure that you need a lot more test coverage when it comes to running latest and greatest. On the other hand, using pinned versions, so specifically saying, I want to run this operating system base version, I want to run this version of the runtime environment, enables you to more easily figure out if there are any security related things in the CVE database, for example, and it's easier to cover those and then actually figure out if some kind of vulnerability actually affects you. At the same time, you need more manual labor because you have to manually make sure that your stack is keeping pace with the development of operating systems and the runtime environments. There's a controversial topic regarding the update mechanisms because there's a common recommendation to always run yum-y update inside a running container to always pull in the latest operating system updates. I wouldn't recommend that because basically it breaks the one-way street of a build chain philosophy. If you want to change something with your running container, then you should start in the beginning in the build chain. So if we look at one of the base images sent to us, that's a common and known one. Here, one of the questions is, if you do a Docker pull on CentOS, what's the actual image that you're using? If you don't supply a tag, latest is automatically assumed. And that's pretty cutting edge, because waking up the other day and you're pulling CentOS 8 versus CentOS 7 might be a bit of a deal breaker. So on the other hand, specifically choosing a version might also not always be the most clever way, because if you look at the CentOS process, the way they set forth on the Docker Hub is minor tags do not receive security updates. As for the rolling builds, for example, CentOS :7 would give you regular security updates on a monthly basis. So that's just something you have to actively decide. If you want to go with rolling builds, then you need different test coverage strategy, or if you directly go with minor text and then take care of that part yourself. So it makes sense to understand those strategies. So creating base images yourself. So there's at least two ways to create your own base images. So why is that interesting? Well, Docker makes it pretty easy to try out software and run it on a system. And the form you actually use to make that software run are images as a form of transport, if you will. And even if you're building your own software by writing your own Docker files, in a lot of cases, people would pull the base images from the public Docker Hub, like CentOS, BusyBox, Alpine, you name it. The issue is you don't know what's inside. So it's possible to create your own base images, and it's not as hard as it seems, because essentially you just need to create a user land and then put that user land into a tarball and load it into Docker import. So there's two approaches. One would be you install the user land in a local directory. The other one would be, as you might already do, create a virtual machine image, clean this up, remove the kernel, you tar it up. On the right-hand case, you would convert the image to a tarball, which essentially results in the same, and then you can directly do a Docker import and load that image. Luckily, the distributions already help with that. So on the left-hand side would be the Debian debootstrap approach. On the right-hand side, it's the appliance creator from Fedora CentOS. So next, credentials. So there's questions like, how does the whole Docker build chain credential management interact with my existing configuration management, if you have any? Should I put credentials in images? Or should I put the credentials in environment variables? So using configuration management, you were used to bake the credentials into the process and then onto the running machines during the deployment process. So the existing static configuration management tools that I know, that we know, did not really reflect container solutions per se. So they're not built for this type of process specifically. One idea would be to directly store those credentials in an image and then run it through the build process. But you could accidentally then push that image to the public Docker Hub, because if you don't supply your own registry, then it would go to the public Docker Hub. And maybe you unfortunately already have a username and password set forth for that, and then all your productive configuration and application code would be uploaded. So one alternative would be you could pass those credentials as environment variables when starting a container. Unfortunately, stuff like Java is not able to actually support that, so you need to then work around that. So what to do about this? One idea would be to use credentials in a separate data container, but then you would have to make sure that they're encrypted, and probably would be a good idea to actually use asymmetric encryption, because then the ones consuming this configuration container do not necessarily have to be the same group of people that are actually producing that container. And group of people could also mean your build chain. But you would have to set up a PKI probably, so there's some effort involved in there. Another option would be to use key value stores. There's one approach would be to, if you dig into the HashiCorp chain, would be console with the add-on of Vault, which would enable you to do that. Another option would be, for example, to use Conjure. That's a commercial solution that will also work as a security management suite here in this for this idea. The third one, probably the one which would involve the most effort but gives you greatest flexibility, is to create an agent that actually does the injection for you. So one of the projects I've been working on last year, we actually did this, created an agent that took care of this injection, and then used this service to actually create, this was based on AWS, so it created the test definition file to actually post it to the ECS cluster, and only this agent was able to decrypt the encrypted configuration values that were stored in a private Bitbucket repository. So the key takeaway would be, we think unencrypted credentials should not be part of images. There are alternatives. And now after discussing the build chain part, let's move on to storing and registering those images, so the registry. Primarily, the registry is for managing repositories from various publishers and the images contained therein. So after creating an image, the common way to ship them is to actually to ship them to the execution environment is to upload it to a registry. It could be a public one, or it could be a private one, which is you could use as a software as a service, or could also be one that you run yourself on your premise, like Docker Registry or Docker Trusted Registry. So if we look at the Docker Hub, at the public version, and at the CentOS repository, just to emphasize the aspect of actually looking into what you're pulling in from the public Docker Hub. And CentOS, I would say, I pulled this last week, so it's not uncommon and not unknown, but still there's some caveats. If you look at the link here, it provides you with a GitHub link to the repository, which hosts the Docker file that is actually being pulled in while building those images. And if you look at the file, you see, okay, from scratch basically means that Docker would start from nil and really build this from scratch, as it says. But the add c7-docker tar xz line, well, you wouldn't find the contents of that tar file anywhere, so you don't know what's actually inside. So Docker is using the term official repositories to strengthen the trust in those images. At the same time, there's no real distinction between a clean and a dirty image. So the Docker engine would handle both in the same way, so there's no level of trust. The only difference is you can see here on the website, one says official and the other one from us, it says public. Okay. So maybe you still remember how easy it is to create your own images from scratch, and maybe that just became a little better idea. So, because even if you answer the question, do I trust upstream with yes, there's still a gap in the creation process, and you cannot fully trace that. So, but things are getting better. So, so one way to improving this and to answer the question what an official repository is, Docker introduced the so-called digital signature verification in Docker 1.3. So that's quite some time ago. And this was for official repositories only, and it was a non-functioning stub. Even worse, even when it spit out an error message, the image was still loaded. So that's probably not the best approach that you could take. Now with Docker 1.8, they introduced the so-called notary server component, which is based on the update framework and basically verifies signatures of image hashes. So the notary server is now a component which is part of the Docker daemon registry and client process, which takes care of verifying the metadata, and only if this is correct actually runs the image. So in order to get this going, you would have to create an offline key and a tagging key, and the tagging key is unique for each repository. And so whenever you try to push an image to the Docker Hub or to a privately run notary server / registry, then you would have to actually sign the image hash of that image, which means you would have to supply your build chain with the password to the X509 private certificate to actually do this. So you would have to take special care to actually secure your build environment if you're trying to do that. So, so we already discussed that. this is what it looks like if you enable the so-called content trust feature. So it says no trust data available if I try to pull an unsigned image. Now here's a hidden step. For brevity reasons, I left that out, but in the notes to this talk, there will be links provided so you could have a look at it yourself and actually play around with the notary server component. The hidden step is signing the image. So actually created an image and then signed it. And now it looks like that. So it's not really, in terms of user-friendliness, very easy saying successfully verified. It says status downloaded new image, tagging, and you see the SHA-256 hash. So that's basically the magic telling you a lot of lines. So little lines, it's not good. Many lines, that's good. So I think they can still improve that. So it still does not solve the question if you trust me to create backdoored images, but at least you know the backdoor would be from me. So it's progress. So next step would be the Docker host itself. So we now covered the build chains, created the images registry to store them, and now the actual execution environment would be the Docker host, where the images are run as containers. A Docker pull would transport an image from the registry to the loading zone on the host. So that's basically the port in the image. And the container ship itself is not directly tied to Docker, because it's basically running a standard Linux kernel and using standard technologies to actually make processes run. So that's just important to keep in mind, because it means you can apply many security techniques that people used to use before and that were perfectly fine, and apply those to the Docker and container world. So at the port and also on the container ship, there are safety rules to be followed. And basically, it's all to help you setting sail with a secured cargo. So there's basically steps like hardening the host itself. This means disabling services you don't need, remove packages that you don't need, enable local firewalling. So actively decide if you want to run IPv6 or not. That's something people tend to forget. Using sudo versus giving root to everyone, and using no executable mounts, for example. It's just a tiny a bit of examples that you should do there, but just to tell you, all those measures should still be done, no matter if you run Docker or run a normal virtual machine or if it's physical iron. So it all applies here. Then there's SLinux and AppArmor. So SLinux more in the CentOS Red Hat area, and AppArmor for Ubuntu. Basically, those are Linux security models, so they're directly tied into the kernel. They have a userland and a kernel component. And when you're using Docker from the Red Hat Fedora repositories, it already comes with a default SLinux context and protects the daemon and also the running containers. And if you run a Docker on Ubuntu, there would be an AppArmor profile which does not confine the daemon, but at least the containers running. So that's some starting point there. Another topic would be the audit daemon. That's very classic, just for forensic analysis if actually something happened after a security incident. It's easily doable, but often forgotten. Only makes sense if you have a central logging environment. So if I, as an attacker, are able to actually taint the local log files, then that's no use to you. And probably not the easiest part would be GR security. That's a set of kernel patches. And basically, there's many functionalities in there. One of the key components is packs. That's basically you can mark the stack as non-executable and the program memory as non-writable. So this would give you some protection there. Address space layout randomization would also be part of that. The hard part is you need to compile a kernel yourself. So you need to make sure that this actually works. And you need to somehow, if you want to have all the latest changes, you need to buy in, because sometime last year, the GR security group actually made it somehow closed source, so only if you are supporting the GR security course, you would get the latest updates. That's due to the fact that there are people using open source software in their commercial products without actually saying so. Still, that's worthwhile if you have a big environment that's actually running Docker hosts. It's worth investigating because probably you will have to do some customizations anyway. Station 4, the Docker daemon. In the smallest case possible on the Docker host, there would only be running the daemon, right? And then all the containers, of course. But that makes the daemon quite an interesting attack surface. So why is this something to actually worry about? Well, it's the cheesy bit, as I said. It's basically like Swiss cheese, not as tasty, but with all the holes. So the daemon runs as root. The API is pretty extensive with a lot of functionality, and if you can gain access to the API, it basically means you root on the host. Okay, this is new. So yesterday, Docker released version 1.10. And actually, they do offer authentication, and until yesterday, not in a stable release authorization, but at least you're now able to create authorization plugins, which would enable you to actually build an authorization yourself. So I haven't seen any plugins yet emerge, but at least the API would now be able to use those plugins. So that's a step forward. Yeah, I already covered this one. So what to do? Put some slices of bread around the cheese. The holes won't go away, but at least you don't see them anymore. So one would be isolating the daemon. For SO-Linux, there are defaults to actually be used. For AppArmor, you would have to build something on your own. Enable auditing, we already had that. At least this would help you with the forensic analysis, and you should define the access path to the API. We'll get into that in a bit. So how does it look like? That's the example for a CentOS box. When you start the Docker daemon and enable SO-Linux, you see that the Docker T is a domain type, and the Docker daemon is already confined in that domain type. And when you start a container, this one already has a default domain type attached to it. So there's more output for Ubuntu, but essentially it's pretty much the same. Here you see this one is the result for the Docker daemon. It's unconfined, and the last line would be Docker default profile for the containers. So that's if you use Docker from the Vivid repository, this is already default baked in. So there's not too much of a stretch to actually implement that. So restricting access to the API, what's to do about that? One would be to actually make the Docker API accessible via the socket file, and then use SSH to enable access to the hosts. And then you would have to make sure that the permissions on the socket file actually do not allow users to become root easily. So you would have to make sure after starting the Docker daemon that you change the permissions. That's not really viable. Another example would be allow the Docker API via the network. You are able to use TLS certificates on the server end. That's simple, but also on the client side, you could at least do authentication of all the clients accessing the Docker daemon on the host. And then, of course, disable the socket. Third approach would be an agent-based approach. I already discussed this a little bit. So basically, the agent would also enable you to do your own authorization. So that's another advantage. Disadvantage is that's effort you have to put in yourself. AWS has this built in. If you use ECS, and you can use the IAM module to have actually identity and access management on top of that. That's one of the examples, but it's also possible to do it yourself. And now, new, the plugin features, just for completeness. It's available since yesterday. I didn't really have a chance to play around with that yet. So I assume that there will be plugins emerging pretty soon to integrate with existing solutions, and probably even new ones. But that's something to actually watch out, because it basically means that it's basically 1, 2, 4, and 3 in terms of complexity, probably, if you try to order the list. So containers at runtime. So we did everything to actually build secure images. We found a secure way to actually ship those images to a registry and then onto the Docker host. And now we're actually ready to start the engines, almost. So to stay in the picture, the loading time in a dock might be 2 days, but the ship would stay at sea for maybe 30 or 40 days. So transferred to the IT world, this would mean that operations spends a lot of time managing the life cycle of containers. And instead of managing just a running system, the task is more managing a system that is continuously changing by cycling through those containers. So and any change could also have a security implication in this case, because some kind of harmless component that you develop might suddenly become very security relevant in your environment. So which options do we have to actually change the security settings of the containers during the runtime? That's a couple of essential steps. One would be, it's the obvious one, don't run containers as root, but use the user directive. Try to not run them as privileged, because basically this would enable a container to have basically root-like permissions on the host itself, and try to use volume and device mounts read-only if possible, or even better, just use read-only on the container itself if you already built a successful immutable infrastructure, then this would be the way to go. Only expose the ports that are necessary. If you're working around building your system, this might always mean that you're trying to play around with different variations. Always make sure that at the end that you're trying to restrict the access to the version that you chose to go live with. And set up container native logging and monitoring. That's probably, you could do an own talk about this topic. It bit us heavily last year during one of the projects, because it was quite difficult to actually do debugging if you don't have that available. You end up with a black box, or even worse, with multiple black boxes. So, and now, new, you're able to use user namespaces and remap, since Docker 1.10, to actually remap Docker container IDs to other users on the host. So actually you can, to the container, it would look like it's root, and on the host it would be mapped to a different user ID. This comes with a couple of caveats, but it's possible, and it's in the current stable Docker release. That's something very nice. All right, so a little more advanced topics to just briefly cover. So namespaces were released. That's the last time we did this talk. This was still a wish and still work in progress, so that's nice. Capabilities. You're able to actually use cap drop to run containers with the least amount of privileges that you actually require. Not every container needs to change the time, for example, or do a set UID or set git, or change the network settings. Probably most actually don't. You have control groups. They would enable you to actually restrict the resource usage. That's a very nice feature if you think of how to actually run a multi-tenant system with a lot of different applications on one host. So just to make sure that that you don't run out of memory. We already covered SLinux and AppArmor so far. For AppArmor, there's also one of the Docker people started working on a tool to actually auto-create AppArmor profiles. It's called Bane. Exactly, yeah. So that's also something to look out for. And the last part would be seccomp, which is a Berkeley packet filter to call to filter system calls to the kernel. So that's another way of actually restricting the calls that can be made to the kernel. So in the past you were only able to do this if you used the LXC driver, but since Docker 1.10 this also went general available, so you're now able to actually use seccomp also with libcontainer. So now you have all those advanced features in place. you should not try to actually only enable them in production and do as you used to do in the development integration environments. We strongly recommend that you bring in those topics in the front of the change. So those should also be rolled out to your development integration environments. And of course, you need to verify them with test automation and a good test coverage. So this problem does not go away. So as we're already speaking about testing as a topic, we spent some time going through the life cycle of a Docker image container on its way to production. And now, at various stages, it makes sense to actually do some kind of verification of those security measures. So how to actually work with that. You're not alone, and on your own, there's one thing to start off is the so-called Docker security benchmark, which has been released by the Center for Internet Society and Docker Inc. And it already includes a couple of test routines, and there's also tools available to actually automate this part. So there's one which is 100% shell-based, which is Docker Bench security. It closely reflects the Docker Bench security benchmark. There's Batten, which is Go-based and also lets you create a configuration policy. And last but not least, a colleague of mine, Andreas Schmidt, he created a framework based on server spec and Cucumber, where you're also able to create your own tests. So, what to take away? Yeah, basically, hardening remains an important topic, and now it's necessary for containers pretty much the same as for all the other physical and virtual systems that you used to run in the past. So it's other tools, but the task remains the same. Containers could be seen as virtualization on the kernel layer, so maybe they're not on the same level as virtual machines. At the same time, they don't have to be because they ideally only run one workload and not like a virtual machine dozens. So this also simplifies the enabling of those security measures that I described earlier, because you only have one application component that you're trying to confine. That's a lot easier. So in that sense, we would see Docker as some kind of user interface for security. Yeah, and things are still work in progress. So that's not the first time that preparing a talk and the next day there's already a range of new features available. So things are really moving fast in that space currently. At the same time, things are moving forward in a sense, looking at security. So I would say there's no magic to it other than do it. Thanks. Time for some Q&A.
Thank you very much. So, first question.
Hi, thanks for your insights. So 2 questions. One, do you think this ever be, quote unquote, easy for people not so familiar with all this technical in-depth? Do you think the tooling will solve a lot of this problem? Mm-hmm. And 2, what role do you see for unikernels or hypervisors in this landscape? Will this make it easier, or is this just another thing that's going to blow up?
Yeah, okay. So the first part of your question regarding will there be an easy way or an easy answer? So I think that things started to be complex and you had to raise awareness of security measures in the container space. In the beginning, you had to build your own stuff. And now Docker is adapting more and more of those features so that they're really trying to actually work in that space and make things easier. So I think the more they progress with those security features, the easier it will be for you to use because they're actually integrated into the existing core, if you will. So I think there are some measures that will be easier. As I said, with the Bane AppArmor profile creation stuff, that's things they're working on, which will make life easier, if you will. But there's still essentially, if you look at the overall system, you would still have to spend a considerable amount of time to actually implementing proper security. This will not go away. There you go. So for the second part. That's a topic too long to actually discuss right here. I think it will be different. Let's put it like this. And it will be interesting to see what Docker will do with unicorns. Maybe they will just integrate it into this UI for security, if you will. And then, of course, it will help. It's interesting to see.
Hey, thank you for the talk. And can you elaborate a bit on the user namespace remapping feature that came into 1.10? Because that was quite interesting and looked forward to from the security people.
Mm-hmm.
And you said there were some caveats.
So elaborate means any specific things you're interested in?
Especially the caveats you mentioned.
The caveats, okay. Privilege doesn't work, for example. You also have the issue, you cannot, for file systems, you're not able to confine the file systems. So that's another part, because right now if you pull in images and the image layers, they are shared across you could share them across the containers. So this is also something that you cannot simply completely isolate also the image layers below that. You would have to do that manually right now. So there's some caveats. I think for the normal use cases where you really just run an application workload, I think that this is a great feature because it simplifies, this remapping just simplifies the configuration work that you have to do to actually make your application run inside a container, and also increases security.
A small follow-up question on that. So can you, for instance, take an example of running 2 Tomcat servers on the same machine? Sharing the same Tomcat base image and stuff.
Yeah, you could do that.
But then you would want different users and user namespace remapping? Yeah,
this would be done automatically. You can just say user ns remap default, and then actually the handling is done by the Docker daemon. It would create a user range and then take care of that mapping. Of course, you couldn't run the 2 Tomcats on the same external port, so you would have to map them differently. But apart from that, this should work, yeah.
Anyone else? Okay, that's it. Thank you very much, Dustin.
Thank you.